Hi, my name is Palise and I'm going to present on introduction and objective of this project. So as we all know, we conducted our project in Sungai Lumbing Pahang, and Sungai Lumbing Pahang is known as the tin mining that exists around 1896, and it is founded by the British company, and the town is founded around 1900. And this project aims to help students provide geologic and geotechnical guidance, analysis and design for human development. And the objective of this study is to determine the rock and mineral present in the studies, identifying and categorizing the weathering grades of rocks outcrops, to look at the geological structure has formed in the research region, and to learn how to do switch chamber tests and sample work for the point load test, and determine the quality of the rock mass using RMR. So this is the rock class and geological structures. As you can see here from this diagram, there are normal fault, reverse fault, lateral fault and oblique slip fault. And this is the type of joints that we will learn from this project also. And joints are measured in terms of dip and strike, just like the sedimentary layer, and it's formed a result of rock contraction owing to cooling or consolidation, and many joints are frequently parallel to one another. And these are the type of fault that we will see also on this project. They are artisanal fault, synsaline and monosaline. That's all from me.
Assalamualaikum, my name is Nur Rosnina binti Nisa, and I will explain the methodology of rock mass quality using rock mass rating test, which is RMR. The rock mass rating RMR method, also known as the geometric classification, was described in details by Beniowski in 1976. The reader should be informed that Beniowski has significantly changed the ratings given to many characteristics since this method has been improved over time as more case records have been analyzed. The discussion that followed is based on the classification 1989 revisions. Estimating the strength of rock masses is a topic covered in both this edition and the one from 1966. The RMR method classifies a rock mass based on the following 6 factors. First, unit axial compressive strength of rock material. Second, rock quality designation. Third, spacing of discontinuities. Fourth, condition of discontinuities. Fifth, groundwater condition. And sixth, orientation of discontinuities. The rock mass is separated into a number of structural areas when using this classification system, and each structural region is classed independently. In most cases, a major structural feature such as fault or a change in rock type marks the border of the structural zones. Within the same rock type, there may be instances where considerable variation in discontinuity spacing or features call for the partitioning of the rock mass into a number of tiny structural sections.
Okay, my name is Muhammad Ismail bin Jeffrey, matching number DF21000007. Okay, now I want to explain about the mode of failure of this project. So we will determine the discontinuities of the data. Discontinuities can be defined as any form of mechanical breaks or fractures within a rock mass which can cause tensile strength across the fracture plane to approach zero or even lower. To determine the discontinuities of the data, we have been used the geological compass. Okay, so and next, I want to explain about the plotting process and the dependent waterfall. Okay, in this project, we have 30 data to be plotted. Using the testing paper, we have plot 30 dots on it, which is require focus on the plotting work, or else the result will be slightly inaccurate based on the data. And then we calculate the continent based on the plotting code. So as you can see that this is a continent for this project. Okay, after that, another test paper was used to plot the contour. So based on this contour, we have found 10 contour and 10 center point of the contour. So last but not least is a grid circle. By using this kind of plotting contour method, the slope stability and the failure of slope can be determined. Based on the grid circle, the failure of slope can verify either that is a planar, wedge, circular or toppling. So as you can see that we have been used slope dip direction is 90 degrees, slope face angle is 60 degrees, and friction angle is 30 degrees. Okay, this is data for the grid circle, which is dip direction, dip angle, and this is a joint. Okay, that's all for me. Thank you.
Okay, after that, by see in the unconditional zone, which in the region of upper slope and the friction angle of 30, we could find the intersection between plane, that which is the mode of failure of wedges. Then one of the intersection is intersection of the P8 and P7. The lower angle will be plane A, and the higher value of angle will be plane B, deep angle. After drawing the great circle of A and B, we could find the parameter to find the factor of safety in wet condition and dry condition. Point 1 is the intersection of plane A and slope face 1. Point 2 is intersection of plane B and slope face. Point 2. Point 3 is intersection of plane A and upper slope surface, which is 3. Point 4 is intersection of plane B and upper slope surface, here 4. Then point 5 is intersection of plane A and plane B, which is here. Then all the parameter is input in the formula FOS to find the wet condition and dry condition factor of safety. In the wet condition, we got 1.241, and in the dry condition is 1.726. Then the second intersection in the unconditional zone is P9 and P7. The lower deep angle, which is 58, will be plane A, which is P7, and then the great circle of A and B is draw, the slope surface is draw, and the upper slope surface is draw, and then tabulate the point 1 to point 5 to find the parameter, which is the angle of theta 13, theta 35, theta 24, theta 45, theta NB 21, theta 2 NA, and theta NA and B. Then by calculating the formula, we got factor of safety in wet condition is negative 11.1, and in the dry condition is negative 14. Lastly, there is intersection of P9 and P1 in the wedge failure, which in the unconditional zone. The lower deep angle is 56, will be plane A, and point 1, and draw the great circle of A, B, face slope, upper slope, and then find the point 1 to point 5 to get the distance of deep angle. Then lastly, we got the factor of safety in wet condition is 1.444, and the factor of safety in dry condition is 3.096. That's all for me. Thank you.
This is the result for the rock mass rating RMR at the tunnel. The RMR test was carried out by the windowing method at the end out group on the tunnel wall was selected. with distance 1 meter due to the limitation using the measuring tape to set up the distance. Next, the uniaxial compressive strength UCS is determined based on the average value of rebound hammer SRV by referring to the graph UCS against SRV, where the SRV is obtained by the Schmidt-Hammer test. From the result, the compressive strength is between 5 to 25 megapascal, so the rating is equal to 2. Next is rock quality designation (RQD). In RQD, due to the core is not available, the RQD was estimated from the number of discontinuities per unit volume. From the rock table mass rating system, RQD is less than 25%, so the rating is 3. Next is spacing of discontinuities. From the table of rock mass rating system, the spacing of discontinuity is 6 to 200 mm. The rating is 8. Next, the condition of discontinuities. The condition of discontinuities was observed at the site. All the result of the observation is shown in this table. Firstly, the persistence is discontinuity length is higher than 20 meter. Then the aperture is joint opening is 0.1 to 1 millimeter. The roughness is smooth. The infilling gauge is soft filling less than 5 millimeter. The weathering is slightly weathered, so the total for the condition of discontinuities is 12. Next is groundwater condition. The groundwater condition is observed on the gross eye where the rock mass was in the damp condition. So, the rating is 10 from the table of rock mass rating system. Other than that, the orientation of discontinuities. By observing the worst discontinuity in the tunnel, the strike is selected. Then the dip angle and dip direction were measured by using Brunton compass. So, the result is strike is parallel in the tunnel axis and the slope is drive against dip with the dip angle of 68 degrees. So the strike and dip orientation is very unfavorable, so the rating is negative 12. Next, the rock mass classification were determined based on the total rating of 10. So the result is 23. So based on the table of the guidelines for excavation in accordance with the RMR system, the rock mass can be classified as the class 4, which is the very poor rock. Last but not least, the guidelines for excavation and tunnel support. From the total rating of 10, which is 23, it can be determined that our selected tunnel is categorized as class 4, which is poor rock. The RMR value is 21 to 40. In order to purpose an excavation and support system in the tunnel, total rating from RMR value can be used in this table. So, in order to implement the field research, the walls of the tunnel through the poor rock must be formed in a wire mesh, and the rock board supporting it must be 4.5 meter long and spaced 1 to 1.5 meter apart in the crown. If shotcrete is used to support the tunnel, the crown and side must be each have 100 mm of shotcrete. Tunnel supports, which must be spaced by 1.5 meter, must be made of light or medium steel sets. This picture shows the tunnel sketch and system for excavation. That's all. Thank you.
Okay, this is the result for the rock classification at the Sungai Kenau. Okay, firstly is granite. Granite is an igneous rocks. The chemical compound is acid. The texture is coarse aggregate. It is in color of light. In form of mineral muscovite, brotites, plagioclase, autoclase, hornblende, and it is origin from intrusive. Okay, then the limestone, this is from the sedimentary rock. The texture is fine grain. It is in the color of light. composition of calcareous, carbonaceous, clay, silty, and sandy. The mode of origin of the limestone is mechanical. Lastly is the slate, which is in the metamorphic rock. The metamorphic type is dynamite. The structure of clades of slate is coarse aggregate. The grain is very grain. Their composition of mineral is clay mineral, detrital micas, and chloride. Lastly, the parent of rock for the slate is shale, mudstone, and tuff.
Hello, my name is Marwan Nasruddin and now I present the result and discussion. This research was carried out along CGA limbing the cracker function of late Ensigns to late early Mincens and release the research area, which contains of geologically disturbed thin amalgamated sentences within shell area. The aims of this research area are to identify two geological strong index GSI and estimation the rock masses properties, higher surface discontinuity combination as well tunnel support process for rock belts or structure in the cracker formation. Since this tunnel is made of thin amalgamated sentences with thin shell layer retar, then thin amalgamated sentences with thin celestine layer. The GSI value from set investigation for this study area is 50, dropped from 55 as predicted by researcher. This value was determined by analyzing the surface condition and tunnel wheel type. When blasted and hammering were used in the excavation method, the disturbance factor was set at 0.8 because of the bedding planes share strong, the friction angle was lowered by 5 degrees. The laboratory analysis continents point land load and dry density tested.
For the conclusion for our project is UCS evaluated using the Smith-Chamber test from our result and data. So the table 3 shows that our reading for UCS is between 5 and 25 megapascal, and the result, the rating is 2, and due to the lack of core in RQD, the RQD was computed using the number of discontinuities per unit value as the equation, and according to the RMR table, if the RQD is 25%, the rating is 3. And furthermore, according to the RMR table, the spacing of discontinuity is in range of 60 to 200 millimeter, and the rating is 8. And finally, the total RMR of the 1 square meter window or crop rock mass obtained is 23, and it is indicate that the rock mass is class as class 5, which is very poor rock, and if the excavation work is done, the 10-meter support must be constructed concurrently from the base